Okay. I mean, you would have if you would have joined. Never mind. Moving on. If you did not watch the James Tour video, get yourself some headphones and go out there and watch it. I love you, but I'm kicking you out. Okay? Yes, you may. Go. I want you to watch the James Tour video. It's important. Okay? Hang on. Bon, come back here real quick. Hang on. So if you didn't watch the video, I want you to go watch it now. It's important. I want you to see it. If while you're out there watching it, okay, you miss, okay, if while you're out there watching it, you miss the material related to Albert Einstein and relativity, go back and fast forward through the first half of the YouTube video that I'm going to post and watch the Albert Einstein material in the YouTube video to make sure you've got the content for Albert Einstein. Does that make sense? No pressure on that. You've got the rest of the week to make sure that you're up to speed on that. Does that make sense? Okay. And then most of what we are going to do the rest of this week is exam prep. Okay.
Maybe get like 39 minutes of video.
Good there? Jack. Yeah, just use the speakers on your iPad and just make sure that while you're seated out here, you're out of the way of like Mrs. Nimmo if she's got PE going, and that you guys are spaced out. Does that make sense? Okay. The rest of us in here are going to talk about what's in that video, and then we're going to segue into Einstein from there. Okay? Watch it at regular speed.
I watched the wrong one the other day, so I watched it on. I also not the mathematical.
Did you watch the James Tour video? That's the one you were supposed to watch.
Okay. I knew there was
we weren't supposed to watch
last week.
So last week in class, we watched
The mathematical one.
Mathematical Challenges Theory of Darwin. Over the weekend, we watched Dr. James Tour.
I think I watched the on
See, whatever. So long as you've done Tour, we can talk about Dr. Tour and his material now.
Can I get like a point for this?
Sure.
I didn't realize we were
Okay, hang on 1 second, because I got somebody on a Google Meet. So, Tyler, have you watched the James Tour video? Yeah? Okay, so you're up to speed? Good, okay. Back to this. What?
I was going to say, I didn't realize last week when we were talking about racing cars, that they were nano cars.
Oh, I thought
That's why That's why I said, wouldn't those be like billions or trillions?
Oh. Yeah, because it's not like a car made out of graphene. It's a nano car.
That's why
That's
I
like
was
one of those mini remote control ones. Even then, that
It's-
probably expensive.
I can see that now.
It's microscopic.
Yeah.
My bad. I thought maybe I didn't.
I maybe just missed the nano word because I was very confused.
You didn't hear it either?
Yeah, I was imagining.
That
those
is
little
totally my fault.
I was imagining those little matchbox cars.
I set it up here, I promise you. Okay, I apologize. Yeah, they're nano cars, right? They're not visible with the naked eye.
It's like I thought I would heard that if somebody was making cars made out of graphene that were solar powered.
That's fair. Okay, so that's my fault. What besides the cars?
Yeah.
Okay, what strikes you from what James Tour had to say?
How much the media is contributing to misinformation. So that wasn't
Okay.
new information, but just how wrong something like the guy that put in the Nature magazine and what was it? The other magazine, like the Science Weekly magazine, how wrong that could be.
Okay, go ahead.
I thought it was interesting about he talked about the chemical compounds and how like what it would take to originate or to combine like all the different elements and all the different patterns and like all your A's, T's, and all your letters and still make something in life and how much those matter. And so it's like the odds of everything being formed would be infinitesimally small.
Right. So it's what he's talking about is sort of the chemical probabilities. What we were looking at in that biological fraction, 1/10 to the 77th. That's once you have biological life, right? But you've got to go from, if we're following an unguided natural process, that's something like the Big Bang Theory and what evolution is considered today as a cosmic process, not just as a life process. Does that make sense? Then you need something that takes those chemical compounds and starts to organize them in such a way that the information for life gets organized without information. That was probably the hardest thing for me to get my head around. I think I watched this James Tour video like 4 times. I mean, I think I'm decently smart. You know, like I consider myself a decently intelligent human person. I hope that is demonstrated in the way that I teach. But like, I think I'm a decently intelligent human person. It just took me a while to get my head around the fact that we were talking about information necessary for life being formed without information. It's like how that happens. What else? I'm going to come back to the rest of my thought because I think it's important. But what else? What else did you note? Did you like him? He's kind of funny. Okay. I think one of the biggest pieces of consideration for me in watching what he was talking about is the idea that scientists have to consistently interject something into the process to order it, right? Or to keep reactions from going too far and crystallizing, right? If there's not something to stop those processes, then they're just going to keep going. Which puts us in a camp where, depending on how you're looking at the process of evolution, either it's just not possible, or some intelligent thing has to be manipulating the process. Does it make sense? And that gets into a whole set of philosophical arguments. So I want to highlight with this that there are some intelligent ways to tackle something like evolution, a God orchestrated process that he started and has set ground rules for, and so it operates according to those fundamental ground rules. But God has organized it and set it, so there's an intelligence behind it. Yeah. There's another one that says it's just not possible because intelligent design. And enter somebody like Stephen Meyer, who argues for intelligent design instead. You with me? And then there's a sort of a middle ground that says it's a process God put in place, but God interjects at specific moments in the process to do like Dr. Tour was talking about, right? To keep reactions from descending into decay and whatever else. Are you following me on that? Okay. That middle ground argument is typically referred to, take notes on this real quick. That middle ground argument is typically referred to as a God of the gaps, right? God of the gaps argument. And the God of the gaps argument works a bit like this, and it's not looked on favorably by almost anybody, just so you're aware. A God of the gaps argument says, basically, God was smart enough to start the process. This is like the Miller paraphrase version of it, so just understand that. God was smart enough to start the process, but isn't intimately involved, just interjects at strategic moments where the process has holes or gaps, right? So the Big Bang. I'm going to very colloquially do a sort of a Christianized version of the Big Bang. You ready? God spoke, bang, it happened. Now, let's say God's the one who blew up whatever matter he created to give us the universe that we have. And so we're talking about an organized explosion, kind of like the organized explosions that are implosions of buildings. Yeah? Blow it up in a particular way to cause the building to collapse on itself as opposed to taking out 6 other buildings next to it. Okay. So God organizes the boom, the bang, that starts the process of creating the material of the universe, planets and asteroids and stars and whatever else. Once you get, because it's a God orchestrated process, it'll get to things like Earth where life can exist. And so once you get to the Earth and the chemical stuff that's there, then God interjects at the next step of the process to go from chemicals to biological life, right? And then from that sort of soupy set of bacterial life to organisms that are more complex, right? Combination of cellular organisms into multi-celled things. You follow me on that? And then God interjects to go from this set of amphibians to this set of mammals, to go from this set of mammals to this set of, so on the process goes. And so God lets a process play out and then he interjects into it specific things to move the process along. That is, in essence, this God of the gaps argument. Almost nobody looks on the God of the gaps argument with any kind of favor, especially science, okay? And typically a God of the gaps argument is seen as one of those theologically illegal moves for a scientific discussion, right? We don't have good and sufficient scientific answers for how these processes move along, and so we're just sort of throwing the cards out and saying, well, God must have done it somewhere. Does that make sense? Now, understand that the conversations we're having in here, while primarily rooted in a kind of scientific understanding, they don't necessarily make theological or moral arguments invalid, right? We're going to talk about something in second semester called the ontological argument for the existence of God. And it's not necessarily scientific. It's a theological argument. I'm going to be upfront with you. It's a theological argument, but it's one of the hardest theological arguments to defend. It's also one of the hardest theological arguments to attack. It's kind of like a JFK conspiracy theory. It's like the perfect, you can't prove it, but you can't disprove it theory. Does that make sense? That's part of the problem with theological arguments in a scientific discussion like these individuals have been having in these videos. That doesn't mean, now listen to me carefully here, that does not mean that theological arguments are invalid philosophically. It does mean that they don't answer scientific inquiry. And so if our pursuit is scientific information, then we need to do science. Yes? If our pursuit is understanding and wisdom, remember this is a philosophy class, the love of wisdom, then theology and philosophy and morality, they play a role in answering these questions that science can't reach. Does that make sense to you? Okay. So part of the challenge to us as Christians is understanding when and how we talk theology in frames of reference that don't necessarily include it. And being honest, when science doesn't have answers, that our default is going to be theological information or philosophical information instead, right? Or as something that shapes our pursuit in science, or that we allow to fill in the holes, okay? However, we need to be careful about how we fill in with theological information to not create faulty theological arguments, okay, or faulty scientific arguments based on our theology that we're letting sort of override everything else. Does that make sense to you guys? Is that helpful? Okay. Questions or concerns at that point? Did you like that James Stewart video? Okay. Let's do some stuff with Albert Einstein, okay? And then I'll have some material for you well, I'll give you guys time to work on your exam stuff. And then at least Tuesday and Thursday, if not other days, you will have access to your exam material to be working on it as well. Good? Yeah? Okay. Okay. I'm going to see if I can find a video for Dr. David Berlinski, because one of the videos with Berlinski in it does a good job of talking about the fact that philosophic or theological or morality-based arguments for truth are actually valid pursuits when we talk philosophy instead of just sort of pure science, because a pure scientific approach, Berlinski says, is sort of, actually he goes as far, I think, as to say it's basically dumb. You can't do it. It doesn't work. So let's do some stuff with Einstein. Okay. And then we'll go from there. Right? So at this point, we've talked about Charles Darwin, who gave us a way to understand the world around us by the mechanisms of natural processes, right? Change in the natural world as we can see it and understand it. We've talked about Sigmund Freud, who talked about the human mind and our lack of understanding of the human mind and what's going on in our own heads. And we've talked about Nietzsche, who says if it's all sort of unguided natural process, if it's chaos and anarchy and there is no order to the universe, and no order means no orderer, then the human pursuit is that of power, the will to power. The human pursuit is that of dominance, and the human pursuit doesn't necessarily need accountability to anything other than go dominate your landscape. Okay, so here's where that leaves us. It leaves us with Albert Einstein as the final piece of this four-layered system that will create what we know as postmodernism. So we're going to do Einstein, and then I'm going to sort of shift it to say this is how now postmodernism gets its roots based on these four individuals. Tracking? Yay! Einstein. Okay. We know Einstein. We like Einstein, right? No? A lot of blank stares. Good. You tired? Okay. He's just like looking at me with that 1,000-yard stare. And I'm a little concerned that he's angry with me for something. The fact that he's smiling now is good news. See, half the time I do this just to see, like, because if he was really mad at me, he wouldn't smile. He's like, yeah, that's true. I'd roll my eyes. Or make a snarky comment to Abby Medic. Oh, wait, she's not here. Never mind. Flashbacks to bib theology and doctrines last year. Okay, so what? That was a great class. Einstein. Einstein's involved with a series of things. World War II era, sort of Einstein's heyday, right? The period leading up to and then during the Second World War. He gets involved in two projects that matter a great deal. We know him for his involvement with the Manhattan Project, which is the US-based scientific project to split the atom and create atomic or nuclear weaponry. Okay. which, by the way, the United States has been the only country to actually use in any kind of active combat situation. And we did it twice. This is not necessarily something to be excited about. Okay. So he was involved in the Manhattan Project and figuring out how to split the atom. The other thing that he had a particular interest in and spent a great deal of time on is gravitational fields and light as a kind of combined thing. Because here's what Einstein began to note. If we observe light in the universe, it behaves differently as it encounters bodies, celestial bodies, with mass. Everything has mass, right? So light in the universe behaves light in the universe behaves differently as it encounters celestial bodies. This is the basic premise of what Einstein begins to work on. So it looks a bit like this. If we take a ray of light and we have a thing. Given I did it in purple, we'll call it Neptune. I'm just shooting from the hip here. You with me so far? So if you take a ray of light, as it approaches that object, its directionality changes. It bends around the object. Does that make sense? And then it carries on. So my object in space, okay? Never miss a good opportunity to use a coffee cup as an example, all right? And light, as it approaches, it's deflected by the object's gravitational field. And it's warped around the object, which means that light behaves as if it's consistent of some set of particles. We call those particles photons, right? Because gravity affects the way light operates. It bends it. It changes its trajectory. So Einstein says this, if this is what's going on observably to us, then if we take I don't know how to, I'll have to ask Mr. Dwyer how to draw it because I don't know how. If you take a flat surface, like a plane of existence, what gravity actually does is it dimples the surface. So if you're looking at a plane of existence from the narrow edge, like a sheet of paper, what gravity does by this object is that. And light follows the dimple. Does that make sense? It's space-time. Yeah, you with me here? Okay, so objects follow the material patterns of the universe around them. But gravity doesn't just change directionality or bring objects together, it actually warps the space around the object.
It's not the object itself.
It's mass.
The mass,
Yeah.
which gravity is
Yeah.
connected intimately to mass somehow. By the way, science is still trying to define what gravity is. Because we don't know what it is. We know gravity is the tendency of objects to be attracted to another object.
All objects.
Right, yeah. So on the Earth,
Every other object.
So on the Earth, gravity is the little object falling toward the bigger object. That's gravity. But that's not a definition, that's a tendency. That's an observed, repeated result, right? And we use gravity as a word to describe that tendency. Still with me here? So here's what happens. What Einstein notes is that mass, the mass of an object, and its gravitational forces connected to the mass of that object, it actually warps the space it's in. It's like taking a hammer to sheet metal and creating indentations and dimples, and then rolling a marble along that piece of sheet metal. It's going to follow the indentations and dimples that you've made. Gravity works like those dimples, which means this. The material composition of space is affected by objects, by their mass, and then that effect changes the way things like light operate, because the material of space itself has been altered. Yeah? Tracking with me here. Okay. In addition to that, this gravitational field has an effect on the light in terms of time. And the speed of an object determines how that object experiences time. Yeah? Okay, so let's do it this way. How long would it take human persons to get to Mars? Let's do the moon. How long did it take the Apollo missions to get to the moon? 3 months. Casey, do some Googling. Yeah, do it on your phone. 3 what, Tyler? 3 days?
How long did it take the Apollo missions to get to the moon?
Is it really just 3 days? I thought it was longer than that.
3 hours. 3 days, 3 hours, and 49 minutes.
Yeah, okay, good. Thank you, Tyler. So 3 days.
How long did it take
Attaboy, Tyler.
astronauts to get to the moon?
So 3 days.
To Mars. How long would it take astronauts to get to Mars?
Depending on the position, it can take up to 6 months.
Yeah, about 6 months.
Yeah.
Okay, good. So here's the deal. That's how long it takes us traveling at a particular rate of speed, right? How long does it take light from the sun to get to the Earth?
8 minutes.
7 or 9 minutes.
Yeah. So we'll take the mean 8 minutes. So hang on. Which travels faster, the spacecraft or light? Light. Okay, so here's the deal. So Einstein now starts to say it's not just the matter of the universe that's affected, it's time itself that's affected. So the closer you get to the speed of light, the slower the clock ticks. If you could go the speed of light, time would effectively stop. Or maybe time itself would break down completely.
What happened then?
Well, then, because you're moving through space at a rate where both space and time start to break down, Einstein theorizes you would actually travel through what he calls the space-time continuum. You would actually move through.
It's the Twilight Zone.
That's hyperspace. In Star Wars.
Yeah, no, that's exactly what it is.
Yeah.
You would move through a tunnel.
So like a wormhole.
That's exactly what it is. This is exactly what he theorized. If you could move fast enough through space, you would actually move through space and time simultaneously. Because you moving that fast would warp the space because of your gravitational field. And the time around you. Which means time and space are relative to the observer. That's Einstein. So then space is not an absolute. It gets warped by gravitational fields. And time is not an absolute because the clock slows down the faster you go. What does that mean? That means time and space are not absolute quantities. Time and space are relative to you as you encounter it on your trajectory through time and space. So it's a really, really layman's term example for this. At 17, take the average in here, your current year, 2020, is 1/17 of your lifetime, despite the fact that it feels like 17 lifetimes. Okay? It's 1/17 of your lifetime. So cut the pie, quote unquote, that is your life into 17 slices. Okay. Double that at 34. Each of those 365-day slices is half the size. So time speeds up. And the material composition of each slice shrinks. Your experience of time goes faster because that same time window, 365 days, is less in terms of the fraction of your lifetime. Does that make sense?
Could you explain why parents are always saying they grew up so fast, that kind of thing?
Sure. Yeah, absolutely. Are you with me on this? Okay. Why does that matter? Because in Einstein's day, before his theory here, this is special relativity, by the way. And he does special relativity before he does general relativity. We would think of it backwards, but Einstein's theory of special relativity does this. If time and space are relative concepts, then maybe philosophically this is the leap. And this is not Einstein, this is what happens with Einstein's theory. Then maybe things like God, religion, morality, and ethics are also relative to the observer. Maybe there is not an absolute. Maybe it's all relative. Does that make sense? So here's what you've got. You've got Darwin with a natural way to explain the world that doesn't involve God. Freud, who says our understanding of the human mind doesn't actually work because we don't understand what's going on up here. Nietzsche, who says that the human experience is one of the will to power. And Einstein, who says everything, well, he doesn't say it, but the implication of Einstein's theory is everything is relative, gets you to a place where follow your conscience, if you have one, or if you want to. Okay? Be happy. Get everything you want, even if that means stepping on other people to get it. Nietzsche. because it's all an unguided natural process. And whether or not you're right, morally or ethically, is relative to you, not guided by an absolute, because there is no absolute. God is dead. Tracking with me? When you put the four ideas together, you've created the foundation stones that mark postmodernity and postmodern thought. Postmodernism is generally a willingness to question the absolutes, but these four individuals provide us with foundation stones that say, maybe we don't need the absolute to begin with. And it's a struggle to get to that point until Einstein's theory of relativity. Once Einstein publishes the theory of relativity, the philosophic community, looking at people like Nietzsche and Freud and Darwin and a handful of others, run with this idea, and it totally reshapes the landscape. And we go from modernity with absolutes and seeking to harmonize the absolute with our reality to just throwing the absolutes out the window and basically landing on an Epicurean or hedonistic way of life. The pleasure principle, either self-indulgently, hedonism, or in the absence and avoidance of what is painful and uncomfortable, Epicureanism. And it's relative to each individual person. It effectively becomes a quote, you do you. So long as you're happy, that's all that matters. Questions, concerns? Is that making sense? Okay. Good? You sure? All right. You have your remaining